In this assembly video, I'll be using the following parts: the previously assembled syringe pump, a stepper motor driver board, an Arduino Uno or compatible microcontroller, a 12-volt DC power supply, a Bluetooth dongle, some insulated wires, a wire stripper, a flathead screwdriver, and the USB cable for the Arduino. I'll start the electronics assembly by looking at the stepper motor driver board. It requires at least 3 inputs from the Arduino: a constant 5 volts from the Arduino voltage regulator, a signal for the direction of motion, and a signal for when to step the motor. I'll use a red wire for 5 volts, blue for the direction signal, and a green wire for the step signal. Like this. Connect Arduino pin 3 to the driver direction pin. Connect Arduino pin 2 to the driver step pin. I'll be adding a junction to the red wire to share the 5-volt source. For the purpose of this video, I'll just twist the wires together, but proper electrical connections are required for safety. I'm going to use this junction to supply 5 volts to the Bluetooth dongle. Remember, this is a temporary connection for the purpose of this video instruction. Connect the Bluetooth dongle ground to one of the ground pins on the Arduino. Next, connect the RX pin of the dongle to the TX pin of the Arduino. On the Arduino Uno, that's pin number 1. Now connect the TX pin of the dongle to the Arduino RX. That's pin 0 for the Arduino Uno. The Arduino code is set up such that each syringe pump is defined in pairs of 2 wires, starting with syringe pump number 1 on Arduino pins 2 and 3, and onwards up to Arduino pins 12 and 13. Next, let's work on the motor wires. This is a biphasic stepper motor, so the stator has a total of 4 wires. To determine which wires make up each phase, pinch 2 of the wires together and turn the motor shaft. If those wires belong to the same phase, the motor shaft will be more difficult to turn. I found the pairs for this motor. I'll arbitrarily call the blue and red pair phase A, and the red and green pair phase B. It's okay if the polarity for each phase is reversed. This can be solved later by swapping the lead wires on the driver board. Next, the driver board needs DC power. I'll be supplying 12 volts DC using this power supply. I'll use a yellow wire to connect 12 volts from the power supply to the driver board, and a black wire to connect ground from the power supply to ground on the driver board. The Arduino can be powered directly from the power supply. I'll use a yellow wire to connect 12 volts from the power supply to the Arduino voltage in pin. And lastly, I'll connect ground from the power supply to ground on the Arduino. The last thing to do is to connect a male wall plug. Before powering on the electronics, configure the driver board to its lowest power setting. On this driver, the power modes and microstepping modes are printed on the board. The lowest power setting is 0.5 amps for this model and requires switch 1 to be 0, switch 2 to be 1, and switch 3 to be 0. All the switches should be labeled on the board somewhere. That will avoid the stepper motor from getting hot while we work. Now plug in the power supply. If everything was connected properly, there will be a lit LED on the driver board, the Arduino, the Bluetooth dongle, and in some cases, the power supply.